continue on with section 4.1 on increasing and decreasing functions. Today we're actually going to get to the increasing and decreasing functions part. Last day was just kind of intro stuff. Let's head down here. We're going to look at functions, as we almost always do in high school math. And here's a function drawn up here. We're going to call it f, or f of x. And what we're saying here is that a function f is called increasing on an interval I if. So basically, I could probably ask a grade 3 kid if they understood the word increasing, getting bigger. They could probably tell me where on this graph is the function, where's the function increasing, right? If I asked a grade 3 student, or if I asked you where it's increasing, I imagine a lot of you would say it's increasing right here. And it's also increasing over there. But here is where it's decreasing. And what's happening up here is neither. It's not increasing or decreasing. Okay, I hope that's pretty common sense, but what we want to do now is we want to give a more mathematical definition of increasing and decreasing. It'll be very useful for us as we move forward in calculus. So basically what we say is a function f, like this blue function, is called increasing over a certain interval, right? We can't say this whole function is increasing because it's not always increasing, but we can say it's increasing over an interval I if f of x1 is less than f of x2 whenever x1 is less than x2 in I. Isn't that great? Wasn't it a lot nicer when you just looked at this thing and said where it was increasing and where it was decreasing? What the heck does this mean? So let's figure out what this means. Let's just call one of the points, how about this point right here, this green one? I'm going to call that point x1. And I'll call this next hash mark over there, I'll call that x2. So whenever x1 is less than x2, well, that's the case here, x1 is less than x2, it's not as far along the x-axis here, it will be increasing, this function will be increasing if f of x1 is less than f of x2. Well, let's take a look at f of x1. F of x1 is basically the y value of this, right? Whatever the y value is right here, right there, this is f of x1. And whatever the y value is, so another way we could look at it is this amount right here, this distance right here, this is f of x1. Sorry, it's going to be really hard to read, isn't it? Okay, and then if we look at this point on the function, straight down from here, how much is this amount right there? This is f of x2. Or the other way you could look at it is if I move over to the left, over to here, looks like actually it's right where the y-intercept, it's just by coincidence, this would be f of x2. Now, what's bigger, f of x1 or f of x2? F of x2 is bigger, isn't it? It's higher, it's less negative. So is this true? Is f of x1 less than f of x2 at the same time that x1 is less than x2? Yeah, it's true. So if that's the case, then we'll be able to say that our function is increasing. Now for decreasing, it's almost exactly the same. You could probably fill it in already what it's going to say. It's going to say a function is called decreasing on an interval I if f of x1 is greater than f of x2 whenever, now don't get fooled here, this should still say whenever x1 is less than x2 in I. So let's look at that on the same function up here. So let's pick a decreasing part of the function. How about from this green dot moving down? So I'll use a different color. If I call, this time I'm going to call this point right here, this is going to be x1 and this is my x2. So what's smaller, x1 or x2? x1 smaller, it's further to the left. So we've met this criteria that x1 has to be less than x2, and what needs to be true is that f of x1 is greater than f of x2. So let's see, this distance from here to here is how much? It is f of x1, right? It's basically the y value of that green point. Or if I go out here, this y amount right there, this is f of x1. Okay, now if we do the same thing with this point, how much is this? This is f of x2. Or if I move out here, f of x2. So what's bigger, f of x1 or f of x2? Well, I think again it's pretty clear that f of x1 is bigger. It's a higher amount. F of x2, it's starting to go down. So because of that, because f of x1 is bigger than f of x2, we can say, even without looking at the function, that this is decreasing here. See, this is the key. You're probably sitting here going, why are we doing all this? Like, this is so complicated. Just look at the function and you can tell where it's increasing or decreasing or not increasing or decreasing at all. But we don't want to always be drawing these functions. We're going to be dealing with some really crazy difficult functions. We want to be able to, we want to have a way to figure out whether the function's increasing or decreasing without drawing the function. And that's what this is setting us up for. So I know this sounds confusing. It's actually going to make our life a lot easier. All right, big question here. How can the derivative of a function tell us where a function is increasing or decreasing? So do you get what the question's asking first of all? It's saying, if you wanted to know whether a function is increasing or decreasing, a very useful thing to do would be to take the derivative of the function. Why? Well, remember what the derivative of a function tells us. It tells us the slope of the tangent line. So if you look at the slope of the tangent line, and if you have a positive slope, which is the same thing as saying a positive derivative, what this would mean is that the function is increasing. And similarly, if you get the slope of the tangent line and you find that it's a negative slope or a negative derivative, what that indicates is that it's a decreasing function at that point. So let me show you what I mean by this. I'm going to draw some green tangent lines here. So if I pick this point right here, I think we can all agree that the graph is increasing here, right? If I was to draw the tangent line, it would look something like this. How about if I did it here? It would look something like that. How about if I did it here? It would look something like that. Okay, now all these tangent lines I've drawn have something in common. They're all positive tangent lines, positive slope. And if they have a positive slope, that indicates that the graph is increasing. And sure enough, it is increasing here. All right, now let's do some yellow tangent lines. Let's do it in this decreasing area here. What would the tangent line of this point right here look like? Well, it would look something like this. How about this point right here? Something like that. I missed, but close enough. How about here? Something like that. What do all these tangent lines have in common? They're all negative slopes. Negative slope tangent lines means it must be a decreasing part of the graph. So you can see how figuring out the slope of the tangent, which thankfully we can do by just getting the derivative, will help us see whether the function is increasing or decreasing without even graphing the function. That's the key. We don't want to graph the function. By the way, if we take a look at this point, what's the tangent line look like? Looks like this. Okay, is that tangent line positive or negative? Neither, it's zero. So what would that mean? That would mean it's not increasing and it's not decreasing, and that's true. This thing right here, this function, this part of the function, it's not increasing or decreasing, it's staying constant. It's going horizontally. So let's summarize this last bit here. If f prime of x, in other words, if the derivative of the function is greater than 0 for all the values of x in some interval, then f is increasing in that interval. And if f prime of x, in other words, if the derivative of the function is less than 0, it's negative for all the x's in some interval I, then f is decreasing on the interval. Basically, all you need to remember is positive derivative means the function's increasing, negative derivative means function's decreasing. So let's do a couple questions and we'll be done. Find the intervals in which the function f of x equals 1 minus 5x plus 4x squared is increasing and decreasing. So remember, the key to this is we want to find the derivative. I'm even going to write that down. Find the derivative. Now, thankfully, finding the derivative isn't too hard in this case. F prime of x equals, well, the derivative of 1 is 0 because it's a constant. The derivative of negative 5x is negative 5, and the derivative of 4x squared is 8x. So I'm going to put plus 8x. So if we want to know where it's increasing, what we know is that the function is increasing when what? When the derivative, f prime of x, is positive, when it's greater than 0. So when is that? When is it that negative 5 plus 8x is greater than 0? Well, we can solve this. This is what we did last day. And look, it's just a linear inequality. You don't even need to change this to equals or anything. You can just solve this normally. So how do we do that? We add 5 to both sides. You're going to have 8x is greater than 5. You divide by 8 both sides, you get x is greater than 5 over 8. So I guess we could summarize there. We could say f is increasing on or over, I prefer to say, over the interval 5, 8 to infinity. Or the other way you could say that is when x is greater than 5 over 8. Write it whichever way you want. Okay, now this is probably unnecessary to do this, but we're also interested in where it's decreasing. Okay, well, when it's decreasing, f of x is decreasing when f prime of x is, in other words, when the derivative is, how do we know it's decreasing? It's decreasing when the derivative is negative. In other words, when this is less than 0. So what we're going to do is take this same derivative here, this negative 5 plus 8x, and we want to know when is it less than 0. Well, this shouldn't be too surprising. Once you solve this by adding 5 to both sides and dividing by 8, you get an answer that looks very similar to what we got over here. What's the only difference? The sign faces the other way. Why is that? Well, because with any function, there's only 3 things that can happen. It's either increasing or it's decreasing. So all the points it's not increasing, it's obviously decreasing, except for one point that's really important. What point's that? Or points. The points where it's neither increasing or decreasing. How would you figure where that is? By making it equal to 0, wherever the derivative is equal to 0. So we're actually going to do this next day, so maybe you don't have to bother writing this for now, but wherever f prime of x equals 0, then it's not increasing or decreasing. Sorry, these are terrible notes, but we're going to do this next day. So we could have done that by doing negative 5 plus 8x. Don't know why I'm doing this, we're doing it next day. We could have solved that, 8x equals 5, x equals 5 over 8. This is where it's neither increasing or decreasing. This is where the tangent line is a horizontal line. We'll get to that next day, okay? Back to this. So what we found is that f is decreasing over the interval negative infinity up to 5 over 8. Or you could say x is less than 5 over 8. So, summary, when x is less than 5 over 8, the function's decreasing. When x is greater than 5 over 8, the function's increasing. When x is 5 over 8, the function's not increasing or decreasing. Okay, this question is similar, just more complicated because it's a quartic rather than a quadratic function that we had up here. So find the intervals of increase and decrease for this function. The way we're going to do that is we're going to find the derivative. So we need to find g prime of x. Not too bad. Power rule says this will be 4x cubed. This will become, when 3 comes down and multiplies the negative 4, negative 12x squared. When the 2 comes down, negative 16x. And that's it. Now, I want to answer this a little bit differently than what we did up here. What we did up here is we figured out where it was increasing by making it equal to 0, where it was decreasing by making it less than 0. But do you see that it would actually make sense to actually start by finding where it doesn't increase or decrease? Do this bit here, and the other points will be where it's increasing or decreasing. So I'll show you what I mean. We're going to find when is it that 4x cubed minus 12x squared minus 16x, in other words, the derivative, when does it equal 0? Okay, well, we're going to solve this by factoring out a 4x, and what we're left with is x squared minus 3x minus 4 equals 0. Then you can factor the middle part here, the trinomial, and two numbers that multiply to 4 subtract to 3 are 4 and 1, so x minus 4, x plus 1. So you can get your zeros here. The zeros are x equals 0. Don't forget this. 4 times 0 is 0. 4 minus 4 is 0. Negative 1. Negative 1 plus 1 is 0. Okay. Now, what do those points tell us? What's happening at this function right here? What's happening at the points when x is 0, x is 4, and x is negative 1? Is the function increasing? Nope. Is the function decreasing? Nope. The function is neither increasing nor decreasing. It has a tangent line that has a slope of 0 at that point, horizontal line. Okay, so these zeros, what we're going to do with them is we're going to put them on our wiggle graph, just like we did last day. So we're going to put 3 points on here, which are -1, 0, 4. Notice the spacing really doesn't matter at all. Now what we're going to do is we're going to see in each one of these intervals whether the derivative is positive or negative. So just like last day, we're going to take test points in each of these regions here, in each of these intervals, and plug them into the derivative. Now, where are you going to plug it in? Well, you could plug it in anywhere you want, but the best place to plug it in is where it is factored. And what I'm going to do when I plug it in, I'm not seeing whether it's equal to 0 or not. I'm plugging it into this highlighted part, and I'm seeing, is the answer positive, or is it negative, or is it neither? But it certainly shouldn't be neither, because these are the points where it's neither. We already found the points that it's not positive or negative. So every one of these points should be either positive or negative slope. All right, let's go. Let's pick a point up here. I don't know, I'll pick 10. 4 times 10, that's definitely positive. 10 minus 4, that's definitely positive. 10 plus 1, that's definitely positive. Positive times positive times positive is positive, so I'm going to write down here positive. I'm just going to put a plus right there. Okay, let's pick a point in here. Between 0 and 4, I'll pick 2. 4 times 2, positive. 2 minus 4, negative. 2 plus 1, positive. Only one negative, which means it's going to be negative. Between -1 and 0, ooh boy, this is hard. Here's why you wouldn't want to plug numbers back up here, because then you're going to have to deal with all these decimals and everything. But it's really no more difficult if you just use the factored part. Let's go with -0.5. 4 times -0.5. Is it positive or negative? It's negative. That's not hard to figure out. -0.5, take away another 4. It's still negative. -0.5 plus 1. If you add 1 to -0.5, you get up to positive. So negative, negative, positive. What's that give you? It gives you a positive. I think every example I've given you so far, they alternate, but this is going to not always happen, so please check all the different regions. Okay, last interval here, a number less than -1. I'll pick -5. 4 times -5, it's negative. -5 take away 4, it's negative. -5 plus 1, it's negative. Negative, 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 multiply them all together, you get a negative. Okay, we're going to end up doing these wiggle graphs a lot. What I'm always going to do is put the negative or plus down here, and what I'm going to write above is what this means. So what does this mean about the function, this g of x function, which I've boxed up here? What does it mean about that function such that we found the derivative is positive right here? It means that in this interval right here, for the whole interval, it is increasing there. What does it mean? Well, obviously it means the same thing here. It's increasing here as well. What does it mean in these two intervals when we found that the derivative is negative? It means that the function g of x is decreasing here and here. And again, what does it mean? I know I've said this a whole bunch of times. What does it mean at this point and this point and this point that we found that those points, they equal 0? The derivative equals 0. That means it's neither increasing nor decreasing at each of those 3 points. So this is probably overkill, but just to hammer it home, we could say that g of x, the function, is increasing on or over the intervals -1 to 0. Should I put square brackets or circular brackets? You should put circular brackets because it doesn't include -1. At -1 and 0, it's neither increasing nor decreasing. And it's also increasing on the interval 4 to infinity. G of x is decreasing on -infinity to -1 and 0 to 4. And there you go. We've done exactly what was asked of us.